Hello class, welcome to this lesson on 7.3 part 2. The learning targets are to be able to use the unit circle to evaluate trig functions of any angle. And the second target is to prove and use the Pythagorean identity to find sine and cosine for any angle. So you can imagine part 1 we covered the unit circle. Part 2 we will cover proving and using the Pythagorean identity. So the review, a lot of this vocab is a review from part 1. However, we're going to focus on the last vocab term, which is the Pythagorean identity. All right, so the essential question is, how is the unit circle related to trigonometric functions? And so we're going to quickly review the unit circle from part 1. So you may recall that for the unit circle, we talked specifically on what the x and the y coordinates represent on the unit circle. So any point on that unit circle can be represented by the cosine for x for the x coordinate and the sine for the y coordinate. So the x coordinate is on a given point on the unit circle is the cosine of the angle that you're interested in for that specific coordinate. Okay, so let's go ahead and show you the animation real quick because we haven't showed you this on Desmos, but just to kind of give you a visual of what we talked about. All right, so let's go ahead and zoom in on this unit circle real quick. All right, so right now we're at the red, which is at 0 degrees. So the coordinates at 0 degrees, you can imagine, is going to be 1, 0. So this is saying that the cosine of 0 degrees is 1. The sine of 0 degrees is 0. Now I'm going to go ahead and change this to another angle here. Let's go ahead and actually change this to let's change this to 30 degrees and see where we're at. Right now we're at a 40-degree angle. So let's change this to 30 degrees. So now for 30 degrees, or for 60 degrees, if I go to the coordinates for 60 degrees, then this means that my x-coordinate, or my cosine of 60 degrees, is 0.5. My y-coordinate is 0.866, which is saying that the cosine of 60 is 0.866. And this is how the reference triangle looks like in quadrant 1. So now let's go ahead and go to do a reference triangle for quadrant 2. So let's look at, for example, 160. Let's do 150 degrees. So the reference angle for 150 degrees is 30 degrees. And so this is the reference triangle for quadrant 2. And if you look at the x and y coordinates, that gives you the cosine of 150 and the sine of 150. So you can imagine using the unit circle is going to help you find the cosine and the sine for different points on that circle. And so this is how quadrant 3 would look like, the reference triangle, and then this is how the reference triangle looks like in quadrant 4. So I wanted to quickly show you that as a quick review of how the reference triangles look like and how to draw them, as well as what the x and y coordinates represent. And this is the diagram that we filled in the previous lesson. So again, talking about here, cosine of 60 degrees is 0.5 and 0.866, which represent the cosine and the sine. All right, so quickly reviewing that, just want to make sure to kind of give you an idea of what we went over. Now that we went over that, I'm going to show you a shortcut for different values of sine and cosine. And we're going to quickly review this before we touch on Pythagorean identities. All right, so here's a quick shortcut that I like to use. I like to show my students for sine and cosine. So let's say you wanted to find the sine of 0 degrees, right? If you wanted to find the sine of 0 degrees, well, what we're going to do is we're going to start every value. We start with sine first, okay? So notice that my special angles are 0, 30, 45, 60, and 90. All right, so we're going to start by writing a square root on each of these. All right, and then each of these is going to have an over 2. Okay, so they're all going to be divided by 2. All right, and then what I'm going to do is I'm going to start from 0 all the way to 4. So 0, 1, 2. So this is going to have 0, 1, 2, 3. Oops, let me undo that real quick. 3, and 4. And those are going to be the values of sine for those special angles. Okay, so we know that square root of 0 is 0. So this is going to equal to 0. So we know that the sine of 0 degrees is 0. And then we know the square root of 1 is 1. So this is going to be a half. So the sine of 30 degrees is a half. For 45 degrees, the sine of 45 is square root of 2 over 2. There's nothing else you can do there, so we're going to leave that untouched. The sine of 60 degrees is square root of 3 over 2. Again, there's nothing we could do there, so that's our value. And then lastly, sine of 90 degrees. Well, we know the square root of 4 is 2, so this is 2 over 2, which is equal to 1. So we know that the sine of 90 degrees is 1. And then what we do now is to find the cosine instead of the sine, we simply reverse the values. So in this case, instead of starting at 0, the cosine of 0 is 1, which was the last value. So we're going backwards here. All right, so we have 1 and then square root of 3 over 2. And then square root of 2 over 2. And then 1/2, and then lastly, we end at 0. So quick little shortcut for finding values of sine and cosine. Very useful tip, and let me go ahead and adjust that. There you go. So that's a quick way of finding sine and cosine. Another quick shortcut is all students take calculus. So this is a really good way to kind of remember what the signs are for sine, cosine, and tangent. Okay, so this is saying that in quadrant 1, all the trig functions are positive. So all students, so all the trig functions are positive here. In quadrant 2, students, S stands for sine. So sine is positive in this quadrant. Everything else is negative. As we're talking about sine, cosine, and tangent. Okay, so sine is going to be positive here. We're only interested in sine, cosine, and tangent. We're not interested in the other reciprocal trig functions, okay? And then for this one, we have quadrant 3, where tangent is positive. So that means everything else is negative. So sine and cosine are negative here. And then lastly, we have quadrant 4, which is calculus. So C for cosine, which means cosine is positive. So really easy way to remember. So now if I give you a quick example here, if we're looking at sine of 240 degrees, well, we know that this is going to be in quadrant, if you look at the quadrants here, this is going to be in quadrant 3, okay? So this is going to be 240 degrees. How do I know that? Well, I know that this is 180, and if I add another 60 degrees to it, that takes me to quadrant 3. All right, so my reference angle is 60 degrees. That's my reference angle. Therefore, I can go and use my reference angle here, and I know that this is going to be the same as 60 degrees. What's sine of 60 degrees? Well, sine of 60 degrees is square root of 3 over 2. So this is going to be square root of 3 over 2. And then is it going to be positive or negative? Well, we know we're in quadrant 3. In quadrant 3, only tangent is positive. So therefore, sine has to be negative. So my answer here is negative square root of 3 over 2. So again, quick way to find those values. All right. So now we're going to go ahead and focus on the Pythagorean identity. So what is this Pythagorean identity? Well, again, I went ahead and included a diagram here. Now this diagram is a diagram of an angle of 60 degrees in quadrant 1. And then we're drawing the reference triangle for that. Remember that the hypotenuse is always going to be 1 because the radius is 1, and the radius because of the radius of a unit circle. Okay. So when we go ahead and draw this triangle, we get the triangle that looks like this, right? And we can use a Pythagorean theorem on that triangle. So remember, a squared plus b squared equals c squared. So we have, our x squared plus y squared equals 1 squared from the Pythagorean theorem. All right, next, remember that x is equal to cosine and y is equal to sine. So we can go ahead and plug those in for x and y. So we have here, this is going to be x, this is going to be y. And then cosine of theta squared, that's the same thing as cosine of squared with the little exponent here, okay? So sometimes we like to write it like that. And then we have sine of squared theta. And we know that 1 squared is going to be 1. All right, so then this identity is the Pythagorean identity. This is the one that we're interested in, all right? So that is the Pythagorean identity. How do we go ahead and use the Pythagorean identity? So what we want to do is take that cosine squared and sine squared and use it to solve for sine or cosine. So if I want to find sine, well, then I'm going to rewrite the identity, and I want to solve for cosine, or solve for sine. So I'm going to go ahead and subtract the cosine squared on both sides. Once I subtract the cosine squared, I'm left with sine squared equals 1 minus cosine squared. And so I need to go ahead and take the square root of both sides to get rid of the square. Don't forget that when you take the square root of, on both sides, you need to include the plus or minus. All right, which is what I included here. All right, and then now the square and the square root cancel, leaving us with our identity here, with our identity for sine, which is plus or minus square root of 1 minus cosine squared. We're going to do the same exact thing for the cosine. We're going to subtract sine squared on both sides to solve for cosine. Then we're going to go ahead and take the square root on both sides so that the squared and the square root cancel. And then we end up getting our identity for cosine. All right, so we're going to put these two equations into good use in the next couple examples. Remember that the sine, this is important, the sine, whether it's plus or negative, depends on the quadrant that you're in. This is why I tried to show you the all students take calculus. So if you know which quadrant you're in, then you know the sign of the cosine or sine. All right, so if you know that you're, for example, you're in quadrant 3, then the value of the sine is going to be negative. All students take in the quadrant 3, only tangent is positive. All right, so we're going to show you this in the next couple examples. All right, so let's look at the first example. So we have, what is sine of theta if cosine theta is 8 over 17 and theta is in quadrant 3? So how does that look like? Well, we know that since we're in quadrant 3 and we're looking for the sine, so if we look at all students take calculus, ASTC, since we're in quadrant 3, we know that the sine is going to be negative, okay? So we know right off the bat our answer is going to be negative. So we have here sine of theta, we're going to be using the formula, Pythagorean identity, equals negative square root, no more plus, just a negative, 1 minus cosine squared of theta. Now we know what cosine is, they gave it to us, right? So we have negative square root 1 minus 8 over 17 squared. All right, and then we're going to go ahead and do the math here. So we got square root 1 minus 64. Now we're going to go ahead and, real quick, we're going to go ahead and type in 17 squared, and that's going to be 289. All right, so now we got to go ahead and subtract those. Remember, to subtract those, we got a 1 over 1 here. So we need to convert this to a common denominator. So we need to multiply this by 289, top and bottom. So we have here 289 over 289 minus 64 over 289. All right. So we have here 225 over 289. And then the square root of 225 is going to be 15. The square root of 289 is 17. So that's going to be our answer. Don't forget the sign. Okay, so it's going to be negative 15 over 17. All right, so that's my final answer for example 1. Now let's look at example 2. What is the cosine of theta if sine is equal to negative 24 over 25 and the tangent is less than 0? This is saying that the tangent is negative. If you're less than 0, that means you're negative, right? So this is saying that tan is negative. So where is sine negative and tangent negative? So let's think about what quadrant that would be in. So all students take calculus. So if you look at first quadrant, all of the trig functions are positive. So it can't be that one, right? Because we just said that sine and tangent are negative. So it can't be quadrant 1. In quadrant 2, sine is positive. So it can't be that one because we said that sine has to be negative. In quadrant 3, tangent is positive. And it can't be that because we just said tangent is negative. So therefore, we have to be in quadrant 4. So this means that cosine is going to be positive. Okay, so cosine is going to be positive. So we know that cosine is going to be positive, and we're going to use the formula for cosine. So it's going to be positive square root 1 minus, now let's go ahead and plug in for sine. Sine is negative 24 over 25. We're going to square that. So now we have square root 1 minus, we have to do 24 times 24. Let's do that real quick. 576 over 625. So again, similarly, we're going to combine this, put this under one common denominator, right? So that's going to be 625 over 625 for 1. All right, we got 625 minus 576. All right, so we'll do that real quick. So we got 49. So we have 49 over 625. And square root of 49 is 7. Square root of 625 is going to be 25. All right, so, and it's going to be positive. So that's my cosine, and that's how you solve the problems involving Pythagorean identities to find cosine or sine. All right, thank you for watching this video with me, guys. I hope you learned something new, and I'll see you in the next one.